Alright, for 61, you're verifying that this equation is true. So I'm working on the left side right here, on this side, and here's what it equals when you use the sine A plus B formula, and then you evaluate whatever you can. So sine of pi over 2 is 1, cosine of pi over 2 is 0, and so 0 times anything is 0, and 1 times cosine x is cosine x. And that's it for that one. For 63, same thing, you're verifying the identity, and so I'm working on the left side. So here is tangent x plus pi is this part, and tangent pi minus x is this part right here. Okay, and this negative is this negative. So tangent of pi is 0, and that's why you see every time you see tangent of pi, there's a 0 there. So here and here. So then that simply just eliminates that one, and that one, and that one, and that one, right? So you're left with tangent x over 1 for the first part, because 1 minus 0 is just 1. And then in the then it's minus, that minus is that minus. So this is negative tangent x over 1, right? So that's what you have right here. So now you have minus a negative is a positive, so that's 2 of them. So 2 tangent x, and that's exactly what you needed to prove. See how it's 2 tangent x? For number 65, here's the, again, I color-coded them so I think it'll be easier to follow. You want to prove this identity right here. So the underlined in red is this part, underlined in blue is this part, and it's just sine A plus B and sine A minus B formulas. And notice how this term and this term cancel out, so that's a 0, and so you're left with 2 of the same term right here. So that gives you 2 sine x cosine y. Okay, for 67, again I color coded it, so here's cosine x plus y, cosine x minus y. We want to make it equal to this. So in the red parentheses is what you get from expanding this. In the blue parentheses here is what you get from expanding this. And this is a product, right? Multiply. So distributive property, this times this gives you this, and then this times this. I should probably draw lines. So here's the first term, and then the second term, then the third term, and then the fourth term. And you see them right here: first, second, third, and fourth term. And notice how the cosine x minus cos, so the two middle terms cancel out, this one and this one cancel out, and you're left with cosine squared x cosine squared y minus sine squared x sine squared y. So what I did is I replaced this one with this, and I replaced this one with this by using Pythagorean identity. And this negative right here is, I'm sorry, this negative over here, because this cancels out, right? These two cancel out. So this is still a negative. That's this one right here. Okay? So then I distribute it here and here. That gives me this. Then I distribute the negative. Well, first I did 1 times that, and then this times this, and then I distributed this negative, and that's how I got negative sine squared y plus, right here, plus cosine squared x, sine squared y. And so again, notice how this term cancels with, do it again, with this term right here, and you're left with this minus this, which is what you needed to get. Okay, for 69, again expanding sine x plus pi over 3 and sine x minus pi over 3. So here is the one for the first one. Here's the one for the second one right here. And you evaluate whatever you can. So cosine pi over 3 is a half. Sine pi over 3 is radical 3 over 2. Same thing here and same thing here. And here you have the next step. And so what you notice is that this term and this term are opposite of each other, so they cancel out. And then this becomes 1/2 sine x. This is the same, 1/2 sine x. Well, 1/2 and 1/2 is 1. So that's how you have 1 sine x equals 1. And so that only happens when x is pi over 2. So for 69 on, we're not verifying, we are solving for x. We're solving the equations, right? So 71, you have tangent x plus pi. So that's what you have right here, a tangent a plus b formula. And then 2 sine x plus pi. Notice I put the 2 outside. And this is all the sine a plus b formula right here. I know that this is 0. This is 0, so that's what you have here. I cancel it out because 0 times anything is 0, so this whole term is canceled. Right here, this plus 0, that's gone. Over here, cosine of pi is -1. Sine of pi is 0. So 0 times cosine x is 0, so that's gone. And this is negative, right, times sine x. So I just put the negative in front, -2 sine x. And then this simplifies just to tangent x. I changed it to sine over cosine. And then I got a common denominator right here. So that now I can write it as a single fraction, and I can factor out sine x out of the two numerators here and here. And so I got 1 minus cosine x over cosine x, so I know that this has to equal 0, and this numerator has to equal 0. Because with this fraction here, if the numerator is 0, then the whole fraction is 0. So all I need to prove is that this numerator is 0, and that's why I have that here. And so for sine x equals 0, it's 0 and pi, and cosine equals 1, that's pi. So I'm sorry, that's 0. Take it back. That's 0. And so you don't have to write the number again, the answer again. So the final answer is just 0 and pi. For 73, we have cosine of a plus b plus cosine of a minus b. So here is the cosine a plus b to here. And then from here to here is cosine a minus b. Okay? And you evaluate wherever you can. So here pi over 4 is, well, I think actually first I combine like terms. So I notice that this one and this one are opposite each other. So I cancel them, they're gone, it's 0. And then these two are the same term, so I just combined them and made it a 2. 2 cosine x cosine pi over 4 equals 1. Well, cosine pi over 4 is radical 2 over 2. Okay? And then here, this cancels this, because remember, this is not an angle. It's not part of the angle. It's its own term. So this whole thing got replaced by pi over 2. So I could multiply this times this. Okay? And so now this I wrote as a coefficient here of cosine x equals 1. Then I divided by radical 2 on both sides, and I got this, and then I rationalized, which gave me this. So cosine x equals radical 2 over 2. That means that x is pi over 4 and 7 pi over 4. For 75, the left side I made it, I used the sine a plus b. There's a formula right there. Cosine of pi over 2 is 0. Sine of pi over 2 is 1. And so this becomes 0 right here. Cosine x times 1 is cosine x. I'm going to move this term over to the left side, which leaves me with this, and a 0 on the right, okay, because I moved this one over. So I factored out a cosine x from both, so there it is, and then I've got cosine x plus 1. and then cosine x is 0, and for the second factor, cosine x is negative 1. So if cosine x is 0, that means that x is pi over 2, or 3 pi over 2. Cosine x equals negative 1 means that x is pi. And those are the answers for x.